Hey there. This video is going to cover chapter 2.4, which is algebraic reasoning, and we're trying to ramp up here and get ready for doing proofs. So all the equations that you solved back in Algebra 1 were, in a way, kind of like proofs, except you never had to like write out your reason, right? You always had the reason in your mind, but you never had to actually formally write it out. So in this video, we're going to practice. We're going to go back to Algebra 1. We're going to solve some equations, but we're going to practice writing out our reasons, right? So taking the thoughts in our mind and then just putting it down on paper. All right. So question number 1 has this equation, and we want to solve it and, of course, justify our steps. So here's what a proof is going to look like in, as we head into geometry. It's going to be what we call a 2-column proof or a T-chart. Okay, so on the left-hand side, we'll have a bunch of statements, and on the right-hand side, we'll have the justification or the reasons. Every proof begins with what's given to you, right? And so we're given an equation, so we'll write 3x minus 7 equals 5x minus 19, and we'll just simply write that that was given to us. All right, now let's think about what we would do, right? So think back to Algebra 1. How would you solve an equation like this, right? There's variables on both sides. There's constant terms on both sides. So what we need to do is we need to try to collect the variables onto a single side and the constant terms onto the opposite side. So I might do something like this, right? Subtract 3x from both sides. And so we'll have negative 7 on the left-hand side, and we'll have 2x minus 19 on the right-hand side. Okay. So the property that I use there, it's called the subtraction property of inequality. If I start with 2 expressions that are equal, and I subtract the same amount from both expressions, then the result is still going to be 2 equal expressions. Okay, so this is called the subtraction property of equality. All right. What might I do next? Well, I'm going to add 19 to both expressions. And so that's going to give us 12 equals 2x. So this time, instead of adding the same amount from both sides of the equation, I added the same amount to both sides. So we call this the addition property of equality, right? Which says if you start with 2 equal expressions and you add the same amount to each expression, then the result is still going to be 2 equal expressions. At this point, what we would do is we would divide both sides of our equation by 2. And that would give us 6 equals x, which is our solution. Okay. So what was that last step that got us to our solution? It was dividing. Okay. So we say that's the division property of equality. Okay. You start with 2 equal expressions, you divide them by the same number, and the result is still 2 equal expressions. So this is our 2-column proof, our T-chart proof. But again, we're doing it in the context of algebra. Okay? Moving forward, we're going to be doing these kinds of proofs with, geometric concepts, angles and segments and triangles and other sort of things. All right, let's do a few more of these. All right, so question number 2, we are given another equation, so I'm going to write this down. 20 minus 2 parentheses 3x minus 1 equals x minus 6. And of course, that equation was simply given to us. So every proof starts with given as its very first reason. Right. Now, you might remember from algebra that when you see parentheses with some factor outside, that we do this thing, right? We multiply. So 20 minus 6x plus 2 equals x minus 6. So when I multiply into that set of parentheses, I'm using what's called the distributive property. So now I see that the expression on the left has 3 terms, one that's a variable, 2 that are constants. And so I know that I can add 20 and 22. I can combine them. So that'll be 22 minus 6x equals x minus 6. So you might have done something like, I don't know, highlight the like terms before you combine them. So here the reason is we're combining like terms, right? So this is what I was thinking in my head, and I'm just putting it on paper. At this point, I have 2 expressions, but each expression has a variable, and each expression has a constant. And so I need to kind of manipulate this a little bit. Let's go ahead and add 6x to both sides. All right, so we're going to have 22 equals 7x minus 6. Okay, so look back at the step I did here in red. I added the same amount to both expressions. So that's the addition property of equality. Okay. Now I'm thinking what my next step is going to be. Well, I want all my constant terms to be on the left-hand side. So I'll add 6 to both sides. And I'll get 28 equals 7x. So again, look back at the last step I did in red. I added the same amount to both expressions. So that's the addition property of equality one more time. And now I'm thinking, okay, if I want to get x by itself, I need to get rid of the factor, the multiplier of 7. To undo multiplication, we use division. So we'll divide both expressions by 7, and we're going to get 4 equals x. We have our solution, and the last step that we took was to divide both expressions by the same amount. So we're using the division property of equality. Okay. So what you did in Algebra 1 was you basically just did what's on the left column here, right? You started with your equation, and you showed your steps. You drew arrows when you distributed, you circled or highlighted like terms, and then you showed all the operations you used to isolate x. Okay. So the only difference now is that we're just writing out the reason for each of those steps. Let's do one last one. Okay, question number 3. The equation is -5 times 2u plus 10 equals 2 times u minus 7. And we always start with the reason that it's just given, right? That equation was given to us. And now it's our job to solve it. All right, I see 2 sets of parentheses, and both have a multiplier or factor in front. So I'm going to go ahead and draw these arrows here, which indicates I'm multiplying to both of those terms. So we'll get -10u minus 50 equals 2u minus 14. So I look back and I remember, okay, when I draw these arrows, I'm using the distributive property. Now this seems to be a common theme in these problems where we get to a certain point where we have variables on both sides and constants on both sides. So we need to do some adding and subtracting now. I'm going to go ahead and add 10u to both sides. Okay, so these opposites cancel each other out. Get -50 equals 12u minus 14. Back at my last step in red, I added the same amount to both sides. So I'm using the additive property of equality. now I'm thinking, all right, well, I want to get u by itself, so let's get rid of this constant term. Okay, so we would need to add 14 to both sides. So that's going to give us negative 36 equals 12u. Okay, I look at what operation I used in my last step. It was addition again. Addition property of equality. All right, and now I need to divide by 12. So the solution will be negative 3 equals u. The last step I took was a division step. So that's the division property of equality. Okay. So what we're trying to do here is just get into the practice of recording our thought process, right? Or recording our reasons or our justification for each step in our solution.